Okay, welcome to pre-algebra day 2. I say that because the camera's on. Welcome to pre-algebra day 2. And yesterday I gave you a worksheet that I was hoping was at one time like, oh, okay, this is something I've done before. And at the other time, at least a little bit challenging so that I can see when I look at these, if you do have a problem with working with fractions or decimals, then I'll know that going in once we get into the textbook. Make sense? We're going to continue that today. I said we're not going to get into the textbook for a while because we're going to continue with your basic math skills. And we've got simple addition, subtraction. Could be simple addition, subtraction, but they're 4 digits. We've got multiplication with more than 1 digit. So we'll get this in your hand. And the purpose of this first week is to diagnose. I'm just throwing some of these at you. Make sure you take one and pass them down. Don't be that person that says, I'm going to pass them down, make sure everybody gets one, because I'd rather not waste time standing here counting papers. And anybody at the back that didn't get one, I'll be back there. You know what I'm saying, Dominic? I don't want to stand here and count papers. It'll take us 3 minutes. Everybody's doing this side first. Math practice A. It's with the addition problems, 4 digits. Yeah, you can start. Worksheet. I am going to send this to you through Google right now. If you are live out there in homeschool land, I want to work on setting up a Google Classroom type thing so we can do this all as one group instead of me individually sending things to you. Still spinning. Still spinning. Not yet. Okay, wherever you're at right now, we're going to interrupt you. Okay? Everybody flip it to the back. Don't start yet. This is going to be a timed exercise. If you're out there in homeschool land and you now have the worksheets, we are going to do the side that says adding, subtracting, and multiplying, and it's got 4 columns of problems, 100 total. There's 25 in each column. If you don't get done, don't stress too much about it. However, mathematics, the most important thing in mathematics is to get the problem correct. Everybody understands that, right? But mathematics, you can't throw out efficiency. You can't throw out getting it correct and getting it done as quickly as you can. Not meaning to stress you out. This is not for a grade. But I am meaning to put a little bit of stress on you. And at this moment, trying to get you to get these done as quickly as you can. I'm only going to give you 2.5 minutes. So that's 150 seconds. That's about 1.5 seconds per problem. Most of them are simple, common, your math facts type problems. Okay, so a little bit of a challenge, but the expectation is that you'll either get done or close to get done. And if you don't, again, there's no tears. It's okay, but you do need to know in math that although accuracy is the most important thing, that you do need to get done as quickly as possible. Is it okay to get done really fast and get them wrong? Never. I want to make sure I'm clear. Is it okay to get done first and fast and get them wrong? Absolutely not. That's awful. Is it okay to get them all right, but take, for 100 problems, take 4 hours to do it? No, obviously everybody's going to say, no, that's probably not right either. Is it most important to get them right? Yes. Is there a time element? Yes. Let me give you a real life example. You're really good at math. You go into engineering or something, architecture. You put a bid on in the future, your company is going to build something for someone, right? You're building it out, say in California. It needs to withstand like a 7.5 earthquake. Okay, it's got to withstand a really strong earthquake. Your company tells the people that want to build this building, I've got the best mathematical minds. Our people are so precise. We're going to be able to build that building so where this steel structure, we've got it down to where the steel will move with the earth as it shakes and rattles and rolls for this earthquake, because that's what they have to do in California, especially these days. They got to build their structures, even their superstructures, to be able to be strong like steel, and they're made of steel, but also to be able to move with the earth, because they get earthquakes. Otherwise, they would just crumble, right? So my company is going to be able to get this job done for you so precisely. We are great at what we do, and we're going to be able to get this building built in 8 months. The other company goes to that place. They got highly skilled people. They're really good with the numbers, and they give them a quote. We're going to be able to get this building done for you. Same price, same quality. We're going to be able to get it done in 14 months. Who's the firm going to hire? The one that's going to get it done in 8 months or 14 months? Right? I mean, that's a wild maybe example for you, but time does play a factor in math, right? When you do Math Olympics when you were younger, was there time involved? Yeah, because what's most important? Accuracy. They counted, when you did Math Olympics, if you knew this or not, it didn't matter if you got them all done. They counted how many you got right. When the graders went through there, they said, you got credit for each one you got right. I don't know if you remember that or know that. So was time the most important thing? No. The most important thing was getting them right. But time plays a part. I spent all that time to explain to you, not to stress out, but it's important to get them right, but it's important to have a little bit of stress to go as fast as you can. Ready? You have 2.5 minutes. Don't start yet. And it starts, if you're out there in cyberspace, 2.5 minutes, and it starts now. We're at the halfway point. Less than a minute. $20 seconds. Did anybody get done? Really? Raise your hand if you got done. 1, 2, 3. 3 people got done. Did anybody if you didn't get done, how many got, and I know some of you are going all over the place, how many think they got 3 out of the 4 columns done? Good? All right. Okay, so the whole point to that was I didn't really expect anyone to get done. But to put a little bit of stress on you to let you see that in math, accuracy is most important. So if you didn't get done, you got them all right, you might be in better shape than the ones that got them all done if they missed any. Does that make sense? Just trying to get you to see that accuracy is important, but so is doing things, the word would be efficiently or expeditiously, to get it done as quickly as possible, right? To not dilly-dally and to focus on what you're doing. Okay, you can continue working, finishing both those pages. By the way, Elise, if there was no stress at all in the world, most people see stress as a bad thing, right? It's a negative. Nobody wants to feel stressed. But if there was absolutely no stressors in life at all, how much do you think would get accomplished? I mean, how many people really have inside of them this driving, burning desire to achieve that we would get a lot done in the world if there was no stress at all, no deadlines, no assignments or deadlines to say you got to get this done? We'd probably be all like cats, laying around, eating, and going back to laying around, right? I mean, how many would be here right now if you didn't have to be? Only a couple people, see? If you had a choice this morning, would you have just stayed in bed?
Yes. Oh, yes.
Yeah, see? I mean, there has to be some stressors in life to motivate us, to keep us going. Now, Mr. Franken's job is to give you just enough of it without overloading you with it. We don't want to, that's why it wasn't for a grade. We don't put you over the edge, but competition brings a little stress, right? Competition's a great thing. Isaac, is it?
Yeah.
Scary moment for me.
Why?
Through the years, I'll introduce the word competition to my fifth graders and ask them if they think it's a positive word or a negative word. And almost every year, I get more negatives than positives. Now, why is that scary to me?
Because without competition, you wouldn't have as much of a drive.
Right. I mean, what would be the reason to do better, right? Again, very few people have like this intrinsic, in them to achieve and do the best they can all the time, unless you're driven to do it. Like even to get out of bed. Some of you literally had to be driven to get out of bed today. Be honest. You didn't get up the first time. I think it's fair to say that there might have been some problems in some households this morning with people getting out of bed. So without competition, yeah, both pages.
What are you doing?
When you're done, just sit tight. We're going to move on in about 5 minutes. It shouldn't be homework because we really, hopefully you're going to be, it'll be homework if you don't get done. So Dina, to answer that question, you got about 5 minutes to get it done before it's homework. But the problem with the word competition when you're a fifth grader is that when you're growing up, usually the reason you think it's a negative is because what do you associate with? The playground or gym class, when someone that you're playing a game with, maybe you don't win and then they make you feel bad, or the person that wins brags, so they ruin the competition for you. So you grow up as a youngster thinking competition's bad, or you grow up with the right thinking that, hey, we all work together, which we should do, right? So you're thinking, well, competition means we're not working together. Well, that's not true either. Now, excited? Yeah, at the end, because not everybody's done right now, so I'm trying to give a few more minutes so that nobody has this for homework. Chapel today? Was it just kind of like an introductory, this is what we're going to do in chapel type deal? There was a speaker? Who was it? Kyle Hop. Yeah, I know. Yeah, Hopsmith. She was a teacher.
Yeah.
Used to.
She did it for like 1 year. Yeah. And then left.
Tough class. Must have been a tough class.
Oh, I think it was the last.
All right, finish up that problem that you're on before we move on. Hopefully you all have a notebook. You have notebook paper here. You got to get that out. I know you're just itching to get those textbooks, but not yet.
You are not there. You're not.
So if you write at the top of your page, and it could be graph paper if you want, but whatever you want to use, you have notebook paper. If you write there at the top, towards the middle of the paper, just that phrase, real numbers. What? I mean, there's such thing as numbers that aren't real? Are there? Bonus question. Are there numbers that don't fit under the category of real numbers?
Yes.
Believe it or not, there are. No, not 11. No, not made up numbers. However, I say not made up numbers, but there's an actual mathematical concept of imaginary numbers. Dominic's like, dude, I'm trying to get a handle on these real numbers. And you're telling me that at some point they're going to tell me there's imaginary numbers? Yeah. All right, real numbers. What are real numbers? Just throw out what you might think a real number would be.
10.
Raise your hand. Be recognized. Go ahead.
10.
Well, 10 is, but yeah?
1.
Sure.
5.
Can you, 10, 5, 1, they're all real numbers. Give me another example of what a real number might be. You're giving me all, well, I don't want to give it away yet. We're going to go through several terms here. Yes? 19, yes?
2.
Okay. You have all given me whole numbers. Okay? Real numbers are whole numbers. You've given me 5, 19, 2, 1. In fact, you've given me all counting numbers. You remember that term? Okay, under real numbers, we have different categories. A category that comes underneath real numbers would be whole numbers. Whole numbers are real numbers. What's a whole number? The numbers you just gave me. 2, 5, 1, 19. Do you understand why they're called whole numbers? There's no halves. There's no fractions. Right? Right. There's no fractions. There's no decimal numbers there. They're whole. Has anything come back to you? Have you talked about these things before? Have you learned these terms before? That's why we're doing it before we get into the textbook. So when you see phrases like this, real numbers, whole numbers, there's other numbers that aren't whole. I should have written whole numbers off to the side more. Yeah. Did you say fractions?
Yeah.
Okay. There are numbers called fractions, but they have a different name. I think I might have mentioned this word yesterday. Numbers that could be written as fractions have a special name in the numbering system. They are real numbers. We'll go a little below this one off to the left a little. And they have a special name. Any number that can be written as a fraction is called a No. A decimal is also this type of number because, well, certain decimals, because certain decimals can't be written as a fraction. You know that, everybody knows that a fraction and a decimal, we covered this yesterday, right? Fractions and decimals are the same thing, right? I can call her, I used you yesterday, didn't I? I can call her Jaden or Michelle, or just not Jordan. It's the same person. So fractions and decimals are the same, and they fall under one category. I don't want to give it to you. I want you to keep thinking. You learned this word at some point before today, and it has to do with, if I was comparing two numbers, I could say 2 to 1, or 2 colon 1, or 2 to 1. Do you remember what that word is? That's 3 different ways to write a ratio. So any number that could be written as a comparison between two numbers, written as a ratio, or written as a
Fraction.
So now did that word come to you? Yeah. What do we call numbers that can be written as a fraction? Or another way of saying a number that can be written as a fraction is a number that is you just said ratio. So what do we call those numbers? Rational. Very good. Rational numbers. Rational numbers, whole numbers are also rational numbers. Should have made a Venn diagram, huh?
Yeah.
Rational numbers are any numbers that can be written as fractions. So, give me an example of a rational number.
3/4.
3/4. 4/5.
20/30.
20/30. 1/4. How about this? Is 12 a rational number? Dina, is 12 a rational number?
No,
Why not?
because it doesn't have a fraction.
That's not what a rational number is. Not a fraction. A rational number, listen, there's a difference. That's why we're doing this. A rational number is a number that can be written as a fraction. So think again, is 12 a rational number?
Yes.
Because I could write 12 as, no,
Or 1/6.
no.
I don't know.
What's another way I could write 12 as a fraction? If I gave you the number 12, I said, you know what, I want you to write it in fractional form.
12/1.
There you go. I knew you were going to get to it. You're just, on the spot, feeling a little stressed there. 12/1, it can be written as a fraction. How about this? 1.6. Is 1.6, Jordan, right, a rational number? 1 point, yeah, because Jordan knows that I could write 1.6 like that, or like that, right? Or like that. Instead of a mixed number, I could write it as a fraction. Does everybody understand that those are all the same thing, right?
Yeah.
So 1.6 is a rational number. All the fractions are rational numbers. Whole numbers are rational numbers. Let's throw another term out there. What's an integer?
Oh.
What is an integer? How's an integer different than a rational number or a whole number? By the way, whole numbers are 0 and counting numbers. Counting numbers are what you learned in preschool. 1, 2, 3, 4. When you add 0 in there, those are whole numbers. Rational numbers, let's write a parentheses there, can be written as a fraction. 12 is a rational number because we could write it as a fraction if we want. 1.6 is rational because we could write it as a fraction if we want. Jonathan, what's an integer?
Negative numbers.
Is it just negative numbers?
Something else I can't remember. It was like negative numbers and
You're missing the obvious.
it just goes back.
Integers
Oh,
aren't just, go ahead.
Isn't it both? Whole numbers and or negative numbers?
Yes, it's your whole numbers, it's your positive whole numbers, and their opposites. Do you hear how I said that?
Yeah.
There's another thing when we go through algebra, we don't necessarily, sometimes it's called a negative number, sometimes it's called the opposite of the positive whole number. So your integers, if that's 0, and this is 1, 2, and 3, these would be called whole numbers so far, right? All I have listed here are whole numbers, but when I put in the other side of the number line, what have I now included? Integers. Integers are your whole numbers and their opposites. Negative numbers are essentially opposites of positive numbers. Does that make sense? So what are real numbers? Real numbers are all the whole numbers, the integers, and the rational numbers. Now here's if there's such thing as rational numbers, there must probably something known as an what? Irrational number. What's an irrational number then? If a rational number is any number that can be written as a fraction, what's an irrational number? Yeah?
Number that can't be written into a fraction?
Like what? How could that be? How could there be a number? And by the way, this word kind of always made sense to me because I'm thinking, that's just if something's weird or something doesn't make sense, I think of the word irrational. You're acting irrational. The way you're behaving right now is not making sense. Stop acting so irrational. So if a number can't be put into fractional form, that is just irrational. Doesn't make sense. Yes?
It's like improper.
Not necessarily improper because is this fraction improper?
I guess we can reduce it.
Reduce it to 3 over 1, right? So it's rational. Improper doesn't make it irrational. What makes a number irrational? Yeah?
A number that you
Can't
reduce.
Number that you can't reduce. So I don't know if they'll be able to pick up. How far can I go? So can I reduce 2 11ths? Can I reduce 2 11ths? Is 2 11ths rational?
Yeah.
Because it's obviously rational because I wrote it as a fraction, right? What makes a number irrational? Or actually, is 2 11ths rational? What's more precise, decimals or fractions? What's more precise, decimals or fractions? Decimals, way more precise. Did you experience Pi Day with Mrs. Reed the last couple of years?
Yes.
Or at least last year, right? What's the value of pi? I want to see how far somebody could go.
No, I was going pretty far.
All right, to the nearest hundred is 3.14, right? And you know from Pi Day that she probably had somewhere, either on her screen or on the door somewhere, where it just kept going on and on and on and on. Right? Right? So, because that gets very precise with a decimal. Does anybody remember what the fraction answer for pi is? If you wanted to simplify pi and not use 3.14, you wanted to use a fraction for that, what would it be? No. You guys did you learn that?
Yes.
Yeah.
Oh, yeah. That's how you divide. Oh, yeah.
Right. So 22 over 7. Make sense? 22 over 7 isn't very precise. 3.141, is it 159?
Yes.
14159, whatever. I mean, you're getting really precise. You're getting down to the like 100 millionths and beyond, right? Doesn't it keep going? Does it go on forever?
It goes on forever.
Is it rational?
No, it's not.
Is pi rational? I mean, we simplify it to make it a fraction. I mean, we say 22 over 7 because because that's the closest fraction we can get. But if it's 3.14 and it just keeps going on and on and on and on, is it rational? Does it ever repeat?
No.
Not that they have found. They don't know yet.
They don't know yet?
They're sure they're still looking. They're like, they have like computers doing it.
So an irrational number would be a number that can't be written as a fraction. What time's this period end?
Right now.
Are you serious?
Right now?
Okay, what's a number that can't be written as a fraction? A number that repeats or that never ends. When you go to do the fraction to decimal, it doesn't repeat and doesn't end. One more day of review tomorrow, and then we'll get the textbook in your hand. And we don't have school Friday, you know that, so we got 2 more days of settling in. Oh, pass those papers.
Which one?
Actually, leave them all on this table.
Which one?
Put all those papers you just did today on that table.
This one?
Yeah.
If you didn't finish, you take it off.
Bye-bye.
You did